All right, guys, welcome to day one. We are talking about some circles today. All right. And the main thing we're talking about here is in the module, not a huge chunk of the exam is going to come from circles, somewhere between maybe 5–10% of the exam. So it's pretty small. And this main chunk of it is tested the least out of the circles part. So we're going to talk about this right now. We're going to get through the unit here. This is stuff that you can kind of get through on your own as well. There's a lot of formulas that we're going to look at that'll help, and some sayings we'll come up with along the way. So the first thing we're going to talk about is the parts of a circle. Okay, so there's four type of lines, really five that we draw in a circle. The first one is a tangent line, not like SOHCAHTOA, Tibet, but a tangent line, remember, is a line that touches only the side of the circle only once. Okay, a secant line is a line that crosses and extends past the circle, and it's going to cross the circle twice. So that's a secant line. All right. If our line does not pass through the circle, so it doesn't go all the way through, it just connects these 2 points on the circle. This is referred to as a chord. All right. And the longest chord that we can draw in a circle is referred to as a diameter. All right, now the diameter is always perpendicular to a tangent line. That's one of the properties we'll talk about a little bit later, but just something to keep in mind as we move along. The other type of a part of a circle we know would be the radius. Remember, it's just half the diameter. All right. The other thing we're going to talk about here is two types of angles. The first one is a central angle. A central angle is always located at the center of the circle. That's why it's called central. And it's formed by two radii. This angle, ABC, is a central angle, and its measure is always the same as the arc. So if this arc is x degrees, okay, it takes 360 degrees to get around a circle, this angle is also x degrees. All right, so if the measure of the arc is x, the measure of the angle is x. Okay, second one is an inscribed angle. Inscribed is inside, and the vertex important is on the circle. Okay, so to inscribe something, it means to draw a circle through its vertices here. So if this angle is, let's say, y degrees, this arc is always twice the measure of that angle. All right, twice the measure of the angle. Okay, so it's on the circle, so it's equal to half the measure of the arc. Twice the measure of the angle, half the measure of the arc. All right, on is half, central is the same. All right, keep that in mind. Okay, going to the back page here, and we're going to go down to the middle of the page here, and we're going to talk about these two right here today. Okay, this first one at the top just mentions that chords that are equidistant from the center are equal to each other. Easy enough, right? Chords equidistant from the center are equal. So if they're the same distance from the center, then these two chords have to be the same length. All right. These lines also must be perpendicular to the chord, because otherwise I could draw them anywhere I wanted and it wouldn't necessarily be equal anymore. Okay. So when they hit the line, they have to form 90 degrees to measure the length. All right. And we'll get into another property there. Second one, this one is referred to as Thales' theorem, okay? And all it says is if I inscribe an angle, right, draw an angle, so its vertices here are on the circle, and the line, this hypotenuse, right, this side of the triangle is the diameter, then this has to be a right triangle in order for this to happen. Okay, remember we talked about this angle is always half of whatever the arc is. So if this is 90 degrees, this arc would have to be 180. And that's why we know that this has to be the diameter, because it has to cut the circle in half for that in order for that to be true. All right. There is one other thing we're going to talk about, and we'll get to that in the middle of the lesson here. So let's get our module books. We're going to talk about Thales' theorem first, but We're going to skip the notes part on it because we just talked about it. All right. And we're actually going to start on page number 4. And let's look at exercise 1. All right. So in exercise 1, we know that AB is a diameter. So if this is a diameter, and this angle is inscribed because the vertex is located on the circle, okay, then this must be forming a 90-degree angle. If the radius is 12.5, now the radius, remember, is any line drawn from the center to a point on the circle. So if this is 12.5, then any radius you can draw, that line, well, not that line, both those lines are terrible. That line, that line, that line, all have a length of 12.5. Okay, so does this side, right? And AC is 7. So the first thing we need to do is find the measure of angle C. That's easy, 90 degrees, because that's a diameter. Okay, AB is just 2 times whatever 12.5 is, which is nice and easy. That's 25. And BC, we're going to have to use some Pythagorean theorem here. Okay, we'll call this side A because it's across from angle A. So we can either use the old A squared plus B squared equals C squared formula, or we can rearrange and do C squared minus B squared is equal to A squared. We're going to use the latter one here. So 25 squared minus 7 squared is equal to A squared. This is going to equal 576, I do believe. And then we're going to take the square root, and that should equal 24. All right. Just double check. Yep. All right. Moving on to number 2. In the circle shown below, BC is the diameter with center at A. Now, because the center is A, we would actually name this circle circle A. We always call it by its center. Okay. And the way these are drawn is such that they're creating 2 triangles. So we want to find the measure of angle DAB, which is this angle right here, okay? So what do you notice? I notice that these lines are connecting to form this triangle right here. Okay, you guys see it? And so we want to know what is special about this triangle. Remember, we're looking for types of lines that are drawn here, right? So I'm looking at this line. It's not really a diameter. I don't know the measure of the arcs or the angles here. This is a little bit tough, okay? But these lines are the key, right? Those lines are both, did you see radii? Because you're right. Good. So these two are going to be equal, which means this triangle is isosceles. And so this is also 18 degrees for the angle measure. And then we can just figure out the measure of angle DAB is essentially 18 plus 18, which is 36 degrees. So the other angle is angle B. Sorry, I won't do that again. All right, which is this angle. And then likewise, these two sides are equal. So these two base angles are equal. So if one is 26, so is the other one. So 26 times 2 is 52. And that's the measure of angle BAE. And then DAE happens to be the 2 angles down here. Okay? So when we add those together, we just have to take this angle, which we know is, oh, you know what? We didn't even finish either of those. Terribleness. Let's go back a minute. DAB is this angle, so we actually have to do 180 minus 36, which is 144. And BAE is the angle over here, so 180 minus 52 is 128. And so these angles on the other side are just the supplements there, so they add to 180. So we know angle DBC here, or it looks like D, I forgot what the middle letter is, I can't see it. DAC, right? That's that angle right there, is 180 minus 144. Sorry, gotta help myself. And that's 36. And the angle on the other side is 180 minus 128, which is 52. And so together, we get 88 degrees. And that's how we get the measure of the angles. All right. Heading over to the next page. So Thales theorem, remember, if I have a the diameter, it's an inscribed angle, then we're going to write right angle. We can flip it around and say that I know if there's a right angle that's inscribed, then it has to be a diameter, okay, for that other side of the triangle, and we can use that here, okay? So, first easy question. We're going to move on here. What's wrong with the picture, right? What's wrong with the picture? If angle ABC is a right angle, booyah, can that happen, right? The answer is no. Okay, what's wrong with the picture? AC should be a diameter. Let's angle B is equal to 90 degrees. All right, so nice and easy. That's all you got to do. Same thing with this one. If this is 90 degrees, that should be a diameter. Doesn't go through the center. Okay, this question right here is a nice Pythagorean theorem question. So if the radius is 17, BC is given. What's the length of AC? So that's a nice one we've done before. All right. We'll take a look at number 4 here, though. I see this little ratio thing that I want to talk about here. So, all right, so I got 24 degrees. We want to find the measure of angle AOB. So remember, we got radius and radius. So this angle is also 24. And this is an exterior angle. Remember the EAT, right? Tells me that this angle here is equal to the sum of the two 24s. Or if you really want to work backwards, right, 24 and 24 is 48. 180 minus 48 is going to give me 132. And that's the measure of this angle. And then we can do 180 from there. So x, or angle AOB, should equal the 48 degrees. All right. And it says the measure of angle AOB and the measure of COD, AOB, and COD is 3 to 4. So what's the measure of angle BOC? Now, we have 48. So what we normally would do is we would attach an x onto these, okay? So angle AOB would represent 3x and COD represents 4x. Now we know angle AOB is already 48 degrees. So we would have an equation that says 3x has to equal 48, okay? Remember, x is referred to as our common ratio. We're not writing that out. So x equals, okay, our common factor or common ratio. We'll call it factor. What are we multiplying both 3 and 4 by? So we get that ratio that works here. And so when I divide out by 3, I end up getting an answer of 16. Okay, so this angle is 48. COD, not drawn to scale, people, okay, on this side is 4 times 16, okay, so angle COD is 4 times 16, and so that, I believe, is 64. We want to know the measure of angle BOC. Two things. One, we know the whole angle here, BOD, is 132, so minus 64 is going to be the difference. And we all can also do add to 180 and then add 64 and 48 together and subtract away. And when we do this, we get a measure of 68. And so that's the measure of angle BOC there. So not drawn to scale, because this looks way smaller than this, but that's how it has to work out based on the ratio they gave us. All right, going to the next page. We're going to take a look at page lesson 2 here. So chords, diameters, and their relationships. So there's three kind of main theorems we're going to learn here. The first one, if you remember, we construct the perpendicular bisector. the biggest thing we talk about here is the football, right? In order to make the perpendicular bisector, I draw two circles with a radius more than half. Where they cross, we put a line down the middle. And any point on that perpendicular bisector has to be the same distance away from A and B, okay? And this is the justification for the theorems we're going to learn here in a second. So this triangle that I'm making here is essentially always going to be isosceles, okay? And if it's isosceles, then we know that these two triangles are equal, so therefore we get a right angle in the middle, and we get these two congruent segments. All right, so if this line is perpendicular, it's going to cut it in half and make that angle 90 degrees. So on page 9, we're not going to prove the theorem. We'll talk about the theorem. But the big thing is, if I take the circle and I put a dot to represent the center of the circle, okay, and I'm just going to draw a chord. So I'm going to draw and connect any 2 points on the circle right there, okay? If I were to create the perpendicular bisector of that line, it's going to have to be the diameter of that circle, guaranteed, okay? Guaranteed. All right, and here's the reason. If I were to draw the radii that connect the two corners of this line, remember what type of triangle it makes, okay? Isosceles. Therefore, these triangles are equal. That angle has to be 90 degrees, and it's going to cut this in half, okay? So if you think about it, we could actually just say, look at, instead of drawing the line down the middle, I'm going to draw in these two lines, okay, which is going to make this isosceles. And if I just bisected the angle here, if I just cut this angle in half, okay, I would essentially create a diameter by doing that. There's the angle bisector. If this is an angle bisector, it's also got to be perpendicular and cut this in half because the triangles are equal, right? Side angle side. And then CPCTC puts all that stuff together. On the next one, this is the reverse. So if, okay, all right, I would draw, I'm straight line tool, guys, okay? Don't do that though. You go away. If I draw diameter, oh, yeah, diameter right there, okay? And I'm going to draw a chord, all right, going this way. So if this chord creates a 90-degree angle with the diameter, then it has to cut it in half. Once again, it's coming from this 90-degree angle thing. So it's coming from these two being equal, right? We got HL, and therefore these are going to be cut in half and all that fun stuff, okay? All right, so keep that in mind. If it's perpendicular, it cuts it in half, the chord, okay? And the diameter cuts the chord in half. If it cuts in half, then the chord it's got to be perpendicular to the diameter. All right. Remember we just talked about it a minute ago too. If these two are equal, that means they're the same distance away from the center. All right. Maybe we didn't do this. All right, we'll talk about this real quick. So theorem: if the two chords are congruent, all right, then they're equidistant from the center. So if these two chords are congruent, then that means they have to be the same distance away from the center. So think about this for a second. Let's say I take a circle. I draw a chord. What happens if I move this chord towards the center of the circle? What's going to happen to it? If you said it gets bigger, you're right, okay? And if I move it further away from the center, it's going to get smaller. So if I told you that I have two chords that are exactly the same distance from the center, okay, exactly the same distance, then that means that those chords have to be equal. So if these two chords are the same distance, then they're equal to each other. Now to measure the distance, this line has to be drawn perpendicular. Must be. Can't draw it anywhere you want. Can't just draw it over here or measure the distance here. It's got to be the perpendicular distance. So that line, OE, is always going to cut CD in half. Okay? And then likewise, if this line, right, is equidistant from the two chords, then I know that these two chords have to be equal. Okay? So we're going to get into some questions here. So take a look at the problem set. Number 1. Okay? These questions involve a lot of right triangles here, guys. I'm just warning you. Number 1. In the drawing, AB is 30. Okay? I'll try to keep this to about 5 minutes here. AB is 30 and OM is 20. Now, as soon as I see this right angle, I immediately have to know that this is going to get cut in half. So if AB is 30, that means these two are both going to be 15. Okay? Now ON is 18, which is different than this. So these two chords are not equal. But I still have to figure out the length of CN. Okay? So, strategy time. Right triangles. Got to try to get a right triangle here to help me out. The way to do it is to draw in the radius. Because this radius is the same length. They're both radii, they have to be equal. So I can use this right triangle to help me figure out what this length is, right? And this thing is the same thing here. So now I can use that to solve for x. Now I'm going to call this c here instead of x because we already have an x we labeled. All right. So in the right triangle, right, MOB, we're going to use Pythagorean theorem. So a squared plus b squared is equal to c squared. 15 and 20 are both the legs. They go in for a and b. All right. So 15 squared plus 20 squared is 625. And then when we take the square root, I am almost positive that we are going to get 25, and we do. All right. So now that I know this is 25, this length is also 25, and I'm looking for the length of that guy. So we're going to do Pythagorean theorem again, except this time we're going to use our solve for the leg formula. Okay. So the hypotenuse is 25, the leg is 18. So 25 squared minus 18 squared is 301. And this is not going to be a nice answer here. So that length A, or Cn, is just going to be the square root of 301. It doesn't say simplest radical form. It doesn't say decimals. We're just going to leave it as a radical. Nice and easy. All right. Number 2. Big thing, perpendicular. Remember we talked about that, okay? So if EF is 12, we want to know the length of this whole side AC. Okay, so perpendicular, remember, means that these get cut in half. All right, so that means this is 12, whole thing is 24. And if these are equal, then the chords are equal. So the length of AC is the same as FD, so this is also 24. That's it, guys. That's it. That's all you got to know for this. All right. We'll try one more. We'll see how it goes. So number 3, make sure we label our stuff. Key thing here, I'm seeing this marked equal, so I know this is perpendicular. Okay, I'm also seeing that these are equal, which means this has to be perpendicular. Okay, and if this is perpendicular, these are getting cut in half. Now it doesn't look like it, but these two lines have to be equal. Okay, because these BG and GE are marked equal. All right, so even before we begin, I know all that stuff. And I also know, that's it, okay? So AC is 24. That means both of these are both 12. Okay? DG is 13. Now GG is a hypotenuse. All right? So what we need to do is if we want to find the length of EG, right, then I'm going to need to know this guy. And remember we said these two are equal because the chords are equidistant. Oh, so that's 12. Not drawing the scale, guys. So don't go by the scale, don't go by the drawing here. And here's our right triangle to help us find EG. So we're looking for a leg again. So we're going to do the old c squared minus b squared formula. If you guys just want to use a squared plus b squared, please, by all means, do so. 13 squared, c, minus 12 squared. Now, if you got your calculator, 169 minus 144 is 25. And we all should know by now that that's equal to 5. And that's the length of EG. All right. One last one. Let's go for 4. Okay. So AB, 10. AC, oh, I don't like this question already, is 16. I'll tell you why I don't like this question. Actually, no, it's okay. These two lines, remember, are both going to be equal. Okay. This triangle's isosceles, so that means these base angles are equal, right? And we got this, and these are equal. Okay. These triangles are going to be equal to each other, and that means that these lines are getting cut in half and we have right angles. That's key here. Okay. We know the length of AC is 16. This is cutting in half here. So if AB is 10 and AC is 16, which means this are both 8 and 8, we want to find the length of DE. Now the key thing is that we know that this whole length has to be 10 because it's also a radius. Okay, so what we really want to do is just figure out that length, and then we can subtract from 10. So we know we got a right triangle. We know it's 10 and 8. So 10 squared minus 8 squared is equal to a squared. That's my a, by the way. So 10 squared minus 8 squared is 100 minus 64 is 36. And then the square root is going to be 6. So if I'm looking for the whole thing, remember this is 10. So if this is 6, that piece is 4. So DE is equal to 10 minus 6, which is equal to 4. All right, guys, that's it for tonight. The next page is a couple more questions involving the same type of thing. All right. If you want to try them on your own, you're more than welcome to. I can put the answers out there for you guys if you want. Kind of some cool questions, a little bit of things here. So take a look if you need to. Remember, the Nearpod is due as well. So after you finish watching the video and you filled out those stuff in your booklet, take a look at the Nearpod. Guys, have a great day. Enjoy yourselves today. Take it easy and make sure you guys stay healthy, guys. See ya.